Welcome everybody. I am Robin Lucier from Michael Plummer Performance, and today we have the distinct pleasure of speaking with Chris Richards from Pro-M Racing. Hi Chris, how are you today?
I'm doing well, thank you. How are you?
Great, thank you. Well today, Chris, we have some questions that we solicited online and we were looking to get your opinion on them.
Okay, sounds good.
Great, thank you. Let's get started. The first question, Chris, are mass air sensors a restriction?
Well, they can be. You can think of a mass airflow meter much like any other part of an air intake system. You have to size it properly. So much like an air filter or a throttle body or even the intake manifold, it needs to be large enough to support the airflow potential or the horsepower potential of the engine. So we have meters in many different shapes and sizes, up to 117 millimeters, and 117 millimeter mass air meter is not a restriction on anything.
So 117 millimeters, how much horsepower would that support?
In the neighborhood of 2,000.
Wow, that's really impressive. Well, Chris, the next question was submitted online. It reads as follows. When purchasing a Pro-M mass air meter, for example, a 92 millimeter to be used with 60-pound injectors, do you recommend the mass air meter be calibrated to the 60-pound injectors or calibrated to the specs of a stock mass air meter and have everything tuned within the engine control module? Either way, with such large injectors, the engine control module is going to need to be tuned.
Right.
What are the advantages or disadvantages of the calibrated mass air meter versus a stock calibration in regards to my example?
Okay, it's actually a good question. We get this one all the time. All right, so let's assume we're talking about a Fox body Mustang. We're going to use that as an example. Okay. When you're buying a mass airflow meter, there's really two things you need to consider. One would be the size of the opening and how much air it can flow. We need to flow enough, physically flow enough air to support the amount of power the engine's making. Mm-hmm. The other part of that, though, is the meter's calibration. So using the stock calibration for a Fox body Mustang as an example, that calibration will read up to 950 kilograms per hour. So we've got a meter housing that can flow enough air to support 1,500 horsepower. If we ran a stock calibration in that meter, it would only be able to read, the calibration would only be able to read up to 950 kilograms per hour, which equates to 275, 300 horse. Whenever somebody's putting larger injectors in their car, we're going to assume that they're doing that because they're making enough power to justify those larger injectors. So let's use a much lesser example for 60 to start. Let's say that the customer is using 30-pound power injectors. They're good for up to 450 horse. 450 horse is going to require somewhere in the neighborhood of 1,500 kilograms per hour. We're going to run out of meter calibration, though, at 950. So the meter's going to reach 5 volts at 950 kilograms per hour. From 950 up to 1,500, there's going to be no change in voltage from the mass airflow meter. Therefore, the computer doesn't see a change in voltage. Therefore, the computer doesn't add more fuel. It's lost. In his example, where we're running 60-pound per hour injectors, that can support as much as 800 horse. We're talking 3,400 kilograms per hour. Again, we're going to run out at 950, so somewhere around a third throttle, this guy's out of meter. Not because it can't flow the air, but because it can't read the increased airflow. Mm-hmm. So, what we're doing when we calibrate a mass airflow meter is we are extending the range of the calibration, the amount of air flow that calibration can read. And we're extending it to a level hopefully just above the customer's potential for airflow or the engine's potential for airflow. And furthermore, when we calibrate a mass air meter to an injector size, what we do is we calibrate the mass airflow meter. The change in calibration of the mass airflow meter is exactly equal to the change in fuel injector size from a percentage standpoint. And what that does is it makes tuning much easier, rather than say, as compared to a universal type meter, which would have a universal type calibration. That calibration may have enough range to read the airflow, but there's more time tuning when it's a universal calibration as opposed to a scale calibration that started with the original calibration.
Great. Thank you for answering that, Chris.
No problem.
Is a slot style mass air meter really more accurate than a tonsil style mass air meter? And are there any advantages of using one over the other?
Okay. The truth is that the electronics that we've been using for mass airflow sensors really haven't changed much since the 80s. What has changed is the way that those electronics have been packaged within the sensor and the design of the mass air meter housings themselves. I think this could probably be best demonstrated if I grab some product. So why don't we do that?
Absolutely.
Okay.
Please do.
Okay, so here's our original mass air meter sensing element from back in the 80s. So they would bolt this to a housing. The sample tube would be inside the housing. The air passes through the front. We get an airflow reading from the sensing wires. The air comes out the back. Problem with this design was that if you had reversion, the air could go back through in the opposite direction just as easily as it could going forward, so there was really no way of mechanically filtering out reversion. So later on we came out with this design, we being Ford, and you can see that they're basically the same sensing element. All they've done now is they've created this tonsil in place of the sample tube. So now the air comes in through the front, it exits out the bottom. If the air was going backwards, it hits a wall, it's not going to get read. So that's an example of mechanically filtering out reversion. Later on, we came out with the tonsil style, the slot style sensor. Really the same thing. The electronics are here instead of here, but if you crack one of these open and you look at the electronics, there's no difference. They've made no advancements in the electronics whatsoever. What they accomplished by using this one, it's thinner. So there's a little bit increase in airflow, but same thing. Air comes in through the front, exit through the bottom. It can't go in through the back. You're mechanically filtering out the reversion. So back in the 80s, Bob Atwood actually came out with the original Pro M design, which started out as a 77. These days it's the Pro M80, the 92, and the 117. But long before Ford or Hitachi figured out how to mechanically filter out reversion, Bob Atwood came up with this design, and it was, I wish I could take credit for it because it's genius. Number one, there's nothing in the air path acting as a restriction for the airflow. Number two, there is this opening that goes all the way around the perimeter of the mass airflow meter, and so the air passes through and it draws a vacuum on this passage, which draws air through the sampling tube. The mass airflow meter sensing element reads the air mass up here in this outside passage. If air goes back through this way, it does nothing. It doesn't read it. And so this was actually the first mass airflow meter to mechanically filter out reversion. Okay, so getting back to the question, is there any advantage to running a slot style sensor over an older tonsil style? The answer is no. This is what Mike Plummer has in his car. And this is the slot style sensor. So is there any advantage to this one? No. They both work exactly the same way. Honestly, the only thing you're accomplishing by installing a slot style sensor in a car that didn't originally have one is making the wiring a pain. You've got to cut the connector off and solder on a connector for this style sensor. This one plugs right into the harness. Use it.
So Plummer doesn't gain any more horsepower with either sensor?
Absolutely not. No difference at all.
Wow. Okay. Chris, can you explain reversion filtering, mechanical versus electronic, and electronic within the meter versus within the processor for us?
Okay. So we just talked about mechanical filtering in a mass airflow meter. Actually, we have a competitor that doesn't use mechanical filtering at all. They have 4 sensing elements in the opening of the mass airflow meter, and they claim to be filtering out reversion electronically within the electronics of the meter itself. I would equate doing that to going back to the 80s when we were listening to music on cassette tapes and trying to get rid of the noise with Dolby noise reduction. You got rid of the noise. The music sounded like crap too.
So that's why the music sounded terrible.
Yeah. So really the right way to do it is to filter it electronically within the processor. A good processor is going to sample the mass air meter reading several times per cylinder event. and there'll be a digital filter in there that's going to filter out the reversion. So between the digital filtering and multiple samples per cylinder event, which are then averaged, you're going to end up with a mass air reading within the processor that's really very, very accurate.
Very good. That's awesome. How does a mass air meter sample airflow, and do some work better than others?
Okay, so again, getting back to the old 80s design, we had the sensing element dropped into the sample tube. That sample tube would actually be inside the housing on one side of the housing. And so the problem with that old design was that it was reading your airflow at one portion of the opening. You calibrated it properly, it worked, but let's say you put an elbow in front of this mass airflow meter. As the air comes through the elbow, it's getting tossed to one side, it's concentrating the air to one side as opposed to the other. So if you were to rotate the meter this way versus this way, you're moving the sampling into and out of the concentrated portion of the airflow. So later on, we moved to this one, and now we're taking an airflow sample at about the middle of the meter, and it's much more accurate doing it that way. And of course, now you can clock the meter, and it'll make a slight difference, but nothing even worth considering. Same thing with a slot style sensor. You drop that into a housing. It's sampling the airflow about in the middle. Clocking it doesn't do a heck of a lot. And then you step up to the Pro M line. There's no sensing element in there at all. Again, you're sampling your airflow around the entire perimeter of the mass airflow meter. So you can clock this whichever way you want. It doesn't make any difference whatsoever. And really what's happening here is, even if the air was getting concentrated more to one side than the other, you've got some true averaging going on here. The airflow is being averaged over, an infinite number of points over the opening of this mass airflow meter.
So Chris, let me see if I have this straight. Rotating the mass air meter does nothing.
In the original design, it certainly did, and that's where that question comes from, I'm sure. But in the modern designs, the ones that we're making and selling now, not really. A little bit with the tonsil style or the slot style. It makes a little bit of a difference. In the case of the Pro M line, the 80, the 92, and the 117 does absolutely nothing.
So myth busted. Well, thank you, Chris, for answering our questions. This concludes part 1 of our interview. Thank you for joining us.